Good morning. So today I've been doing some work on Yann Lecun's course that's for free, and it's out on. Well, let me show you. Uh, Switch over the desktop here, and let me go over here to Google.
To use something like a zero-thought method.
So this has a list here of videos. And here's the first one here, history and resources. And let's see.
So here we go with the record.
Let's see where the URL is for this. I want to show you how to get to this. Well, here's the course website. And here's the playlist on YouTube that will get you there. And I've taken the first two of these so far. And it's very interesting. It's not the simplest thing. Uh, you have to know how to work with partial derivatives. So if you can work with partial derivatives, which are not really that hard, uh, you should be all right. And then, of course, you have to know something about how to do how to get the gradient of a matrix. And we use something called the Jacobian for that. And the Khan Academy has some very good lectures by the same fellow that does One Blue, Two Brown, I think it is. Uh, he has a few videos on the Jacobian that if you go through them, you'll understand it pretty easily, I think. And then at the end of this video on number 2 or 01L on gradient descent and the back propagation, there is there are some instructions that talk about doing a Jupyter notebook. And let me show you where that is also. I'll just make a new one of these and go here. And let's see. Let's see if I can find this now. So what I want to do is I want to look for Pytorch deep learning here. And then here is the original. That's my fork of it. So at cold, and this is Alfredo Canziani's uh, repo, and he is an assistant professor of computer science at NYU and a very nice guy. Uh, and so this is the PyTorch deep learning repo. Excuse me for not being able to talk this morning. I'm not quite with it, but I'm doing this anyway. Uh, so once you make a copy of this, they want it. Alfredo has requested that we make sure that we all do this 01 tensor. And so why not this one first? This is 00. I don't know why not this one. I suspect that this one goes with the first lecture, but there were no instructions for running this. So it's possible that I should run this one as well. And I will take a look at this after I take a look at the 0, 1. And so let's jump over there and see what's going on here. And one of the reasons why I am making this now is because I'm doing this notebook in oh, what is this called here? See, I can't even think. This is Microsoft's Visual Studio Code, and it's a little different from running this in Jupyter Lab or Jupyter Notebook. And I thought I would just go over that, those differences. So first of all, the notation here, these are instructions on what to do. So you can either hold down the Control and hit return, or you can hold down the Shift and hit return. And then it gives you the seconds here, and it updates this counter here. So here, it says for torch.square, it says to hit the tab key. And I guess the tab key will bring up help in Jupyter Notebooks or Jupyter Lab, but it doesn't here in the Visual Studio Code. But I can hover over this, and it says that this is unknown, and I can hover over this. I'm not sure exactly if there's another way to get help with this. It's something I can look up. You can do a quick Google search for that, or a DuckDuckGo search, and figure that out here. So the question mark at the end here does work, though. So if I hit Control Return here or Control Enter, then I will get a list of all the methods that are star tensor. And there are quite a few of them here. And I guess, I'm not sure what this does. Is this going to expand? It says more actions here. Choose MIME type, clear output cells. So I guess this would be all of them then. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like there are 12 of them. 11 or 12. Annotate your functions/classes. So here's a doc string for it. This is just getting help again with the question mark. So I'm not sure what this means. This is just showing us how to do a doc string. I mean, normally you would just use 3 single quotes at the beginning of a doc string and 3 at the end. I'm not sure what's going on here within help. This is using this doc string colon. I haven't seen this before. So this says we can open the raw output data in a text editor. Yeah, I'm not sure what's going on here. I know that this is just defining a neural network. I've seen this done before. I'm not sure what exactly is being taught here with this comment. And so this may be something that's different about Visual Studio Code from Jupyter Notebook. I don't know. All right, let's take a look here at the double question mark and see what exactly that gives us here. Well, this looks very similar, if not exactly the same. Let's see, this is base class there. This is base class. Excuse me. So I just don't know what this is, except for the difference in color. And of course, this has 3 quotes. These are double quotes. But this is how a doc string would be started normally in Python. And this would go to the end. I'm still not seeing the oh, so this is saying there's more output for this and we're just not seeing it. If we want to see it, I can click on this and we can see it. I don't really want to see it. All right, so now it's going into dropping to bash magic. And so if you put an exclamation point at the beginning of a bash expression, it will run it. So I'm going to hit Control Enter here, and boom, there's a ls of my current directory. This is, when I say current directory, I should say that this is the directory that I opened using Visual Studio Code. Now I have my menus hidden because I want the extra real estate here, screen real estate. But if I hit the Alt key, I get my menu here. So that's a file, open folder, or Control K, Control O. If you remember the key presses for that. And then, you know, I set it to the directory where I cloned all of the files from that GitHub repository that I showed you. So that's what we're seeing here. There's a 01 tensor tutorial. All right, so we don't need to see this output. So I can, I don't want to clear all of them. I'll leave that for now. So one of the things that can be done in Jupyter Labs that I like is this stuff can be closed up. So I don't know, this is just running it, it's not closing it up. So I'm not sure how we can hide some of this stuff. That's another thing that I'm going to have to look up. I just started using Visual Studio Code for this because I was unhappy with some of the formatting in Jupyter Lab with dark mode. Some of it just didn't look right. And so this looks a little better, but I'm still not certain that this is the way to go with this. The other thing is I have the Copilot extension installed, but it doesn't seem to work with notebooks. So I'm not getting any help from that. But I am getting some help from tab 9, which at times can be very helpful. All right, so list all the files, but with cleaner output. So here's a for loop. And as you can see, we're kicking this off with the percent dash phrase, which I suppose is giving us bash magic here. Now, what's bash magic? It's just another syntax. So let's take a look at this. Let's run this. And we'll see we're getting more listings here. With doing an ls star and echoing word count minus L. So we're getting the word count here for each F in this listing. So that's kind of nice. Now if we could see the line count for each of these files. And now here we get some general help for magic, and we just run this. And this is very nice that one can get help so easily. So the magic function system provides a series of functions which allow you to control the behavior of IPython itself, plus a lot of system type features, etc. You can read this on your own. And that's something I should do. I should make sure I read this thoroughly. And I'll come back to it. And now we're going to start looking at some things for Torch. And of course, we did an import Torch all the way up at the top. If you don't import it, you can't use it. And of course, in order to import it, you have to have it installed. And so I'm using, let's see, it's not showing me my kernel here. Why is it not showing me my kernel? Because I'm in a notebook, I suppose. But the kernel I'm using is my transformers kernel. So I have Hugging Face transformers installed, and I know that has Pytorch installed properly. So I'm just using that kernel to run this. And is this the kernel up here that I'm using? Yeah, it is. So this is the one that's currently selected here. It's the Transformers one. So I guess what I'm saying here is you take the time to set up a virtual environment and then do all of your pip or conda installations. Go over to Pytorch and follow the instructions. If you haven't seen how to do that, it's not very difficult. You just run over to Pytorch, install, and there's this funny little tool on here that you need to use that's easy to kind of not see that this is a tool. So I'm doing Linux, I'm doing Conda, but you can choose pip instead if you want to choose pip. And it's Python, and I'm using, I think 11, no, maybe it's 10.2 that I'm using, I'm not sure. And then you just copy this here, and you run it from within your virtual environment, and it will install whatever you need for Pytorch for this version. So you can use the long-term support one or the stable one. I probably would not use the nightly one. I want something that's at least stable. Anyway, that's how you do that. If you don't know, and then we can start running some of these here. So this is going to make a tensor with this size here. And let's just run that. And then this is going to show us the size of it. right? And notice that this is a function, so it's inside of parentheses, and it takes a list as its argument. So that when you see these square braces here, that is a list, and it has these values inside the list here, or those elements, I guess would be the right way to say that. And it's also a tuple. So I guess a tuple is a little list here. Let's run this one here. So what is this doing here? This is giving the t size. This is just text, right? It's inside of single quotes here. It's printing that, and then it's printing U00D7. I don't know, is that a space or is that a tab? I have a feeling that's a tab. And it's joining the map function of the string t dot size. So I guess what this is doing is it is making an iterator that computes the function using the arguments from each of the iterables. So yeah, I'm really not certain. Oh, wait a second. This is probably this X here. Let's see if we can find out what this is. U00D7. It is the multiplication sign. All right, so let's take another look at this. And, I wonder why it doesn't show up in front of the 2. So it's grabbing this with a dot join. But I'm not seeing the whole of this. Let's see if I can get this to. Let me try hitting tab here to see if that does anything. It seems to do nothing but move the focus. All right, so I want this dot join, and I'm not getting help. What if I put a question mark here? All right, let's hit the I for insert, and then the question mark, and let's see what happens if I run this now. All right, that's not working. Get rid of that. Let's open up a, all right, I'm gonna hit the escape here and then hit the B. And that gives me a cell below. And I'm going to do a dot join. Oops. What happened here? U for undo. Let's again. Insert dot join. Question mark. So that didn't work, and I have a feeling that let's see if I can get rid of this. I should be able to double D it and get rid of it. There we go. Do the same thing here. I think that somehow let's run this one again, get rid of that funky stuff here. All right, so I'm not exactly sure why this doesn't have a multiplication symbol in front of the 2 here. And I'm not getting this help to work correctly, because you can see that it's just showing me what's in this box, and I'm not able to get the complete function information from here. That's a problem. And so what I'm going to try to do here is see if I can find it here. Control K and Control R. And that's trying to do refactoring. So Control K R. It's not giving me what I want. All right, well, anyway, there's some more resources here that can be looked at. And I'm going to have to figure out how to get the rest of this out of here for the join. So another thing that you may notice here is that I keep scrolling past things. What happened to the... Did I delete that? It looks as though somehow I managed to delete that. Let's see if I can undo it. All right, I'm going to exit from here because I think I've messed it up. Hopefully it didn't save it. Yeah, it seems that I have managed somehow to delete that code. And I'm not getting it back. So that means if I want it back, I've got to go into... Let's try one more time. Control plus Z should undo. All right, so that means I have to go back into the notebook. Good thing I made a copy of it, right? I made a fork, and I can grab that code from there. I'm not going to do that now because this is not going to affect the rest of the notebook. I don't think. Let's run this one here. All right, so it is affecting it. All right, I'm going to stop this now. All right, it seems I'm back recording again. All right, so I got this back, and the way I got it back is I closed this up, and then I opened a terminal and went into that directory, and I just did a git restore of the of this file name here. So that brought this back. So now I have this back to normal here. I have this here, and I should be able to run this next guy here. Just do a control and all right. And so what is this telling us here? 24-dimensional space here. So 4 times 3 times 2 is 24. And it's organized in 3 subdimensions. All right, so I guess that each member of the tensor, of those 24 members of the tensor, is a dimension. And they are subdimensions because they are in different, boy, I don't even know what to call that. Well, I guess it's called a subdimension. Each one of these, this 2 would be a subdimension, so 3 would be a subdimension, 4 would be a subdimension. So if we visualize this as a cube, we'd have our x, y, and z in the cube. I guess that's what that means. And we're seeing a different print, a different way to print here, where we've got F as the formatter, and then this is normally a placeholder. You know, very often what you'll see is a comma here, and then you'll see this t dot numl method thing at the end here, and then it'll get put inside of these French braces. But here, this is put directly in there, so you'll see this very often. This kind of formatted print statement. And let's see what's next here. Now it just has a T here, which means it'll print out the value. So you don't always have to put print first. This works in IPython. It doesn't work in Python. So if you are writing just a plain .py file, you have to put print. But here within IPython, you can just put the variable and it will print it out. And so here's our tensor, and you'll see you have 2 of these, and then there's 3 rows and 4 columns here. So let's take a look up. We have 2, 3, and 4, right? So 2 of these guys, and then a 3, and then 4. So when you're working with matrices, it's always rows and then columns. I'm not sure what we want to call this first bit here, where we have 2. All right, mind the underscore. Any operation that mutates a tensor in place is postfixed with an underscore. For example, x.copy underscore parentheses y, x.t underscore, I guess that's a transform, x.random under n will change x. So what we're doing here is we're going to put some random values. You see here that t is all zeros right now. And when we do this, it should put all random values in here. And here we go. It seems to be all between 0 and 9. So I guess this is the upper limit here. Not sure about that. It's not putting in 10 values because we've got 24 values to fill. So I guess this is the upper bound. And let's see. So it's from and to. Yeah, that must be the upper bound. I'm not sure. I can't really tell from this description what exactly is happening here. But that's not unusual. You have to remember, people write this stuff, and computer scientists are not always the best communicators. I know I'm not. All right, so once again, here's t. I think we saw this earlier. Yeah, and so this is doing it again, so we see the new values that are inside here. And this shows that I guess the reason they want us to run t again to look at this is to show that this underscore here changed the values in here permanently, or by permanently I mean until they're changed again, because this is an in place. Did they say edit or in place operation? Let's go back here. I'm trying to scroll back, and the up arrows are not moving me. What if I use the J and K here? Yeah, K seems to work better than the arrow keys for moving up. And I should get used to using J and K anyway. It's really bad form to use the arrow keys. So as you can see, I hover over this stuff. I don't just go over it quickly. I try to understand it. And as you can see, there's lots of stuff in here that I don't understand. All right, here's the thing I was looking for. Any operation that mutates a tensor in place is postfixed with an underscore. All right, so it's not saying, it's not giving me more of the jargon. That I was hoping to find. All right, so now we're going to resize this tensor, and once again, there's an underscore there. It's r dot resize under. All right, so first of all, we're not going to change t. We're leaving t alone. We're taking t and we're putting it inside of a new variable. We're making a. I'm not sure if this is making a copy or if, yeah, this is making a copy. This is not linking to the same object here. This is making a new object, and then we're going to resize that. And what we can do here, I'm just going to make an edit in here, and I'm going to put t here. So when we're done, we can look at both of these and just run this, and we'll see here's r. Why did this did not show up here? What's this doing here? Let me delete this and run this again. All right, so this is the new size for R. It's 3 by 8, right? So we always go rows, then columns. So it's 3 rows and it's 8 columns here. And so I'm not sure why we didn't see this when we also put the T at the end. Like this. I would have thought that we would have seen both. Run this. Is there not room for it there? Let's try something here. Print. Oops. R. T. And now we're getting both. Now we're printing R and we're printing T. Yeah, I'm not sure why it only printed the last one without the print wrapper. All right, so we're seeing some peculiarities of, it's either of Visual Studio Code or of Jupyter Notebooks. I don't know. I'd have to run this in a separate terminal to be able to tell. And here we're going to zero out the zero out R. We're going to take all of these random elements here and turn them into zeros. And once again, this has an underscore in it, so it's modifying this in place. And there we go. And here's, it's doing T, which I guess is showing you the T. This is interesting because how did T manage to have its values changed? Right, so here was T. T had all of these guys in it. And when I made a zeros here for R, it also changed T. So that's telling me that no, this when I did this R, where is it? R equals torch.tensor T. This did not make a copy of it. This is a pointer to the same object. Otherwise, that zeroing out would not have changed all that. So I guess that's something that I'm going to need to keep an eye on. Yeah, I would have thought that this was actually giving me a new object, a new tensor, but it wasn't doing that. It was just resizing t without actually, it was like it was giving me a view of t that was resized. Very strange. So this is the t maintained its original size, but had all of its values. This is important. Psi, yes, important. So S equals R dot clone. All right. So let's go back up here and try something. I really hate the way this scrolls. All right, so now I've forgotten the syntax already. R equals T dot clone. I think it was, I think that's right. Let's go take a look. All right, let's try this again. Wait a second. All right. So the first thing I need to do is I need to run this again. So this is interesting because you'll notice that everything stayed zeros here. This is going to set this back to have, right? It's important to realize that you don't have to run these cells in order. You can run them in any order you want inside this notebook. All right, so now we've got random values back inside here again. And we can see that. We can print this out again. And we've got random values here. And now we can do this. And you'll see that we've resized this to this, haven't changed the values, and now we're going to set R to all zeros. And there they are. And now we're going to print out T again, and you'll see that T has retained its original values, or original, what we just set up here by doing a random. And yeah, that's important. It's important to know this is going to fill S with 1, and it's not going to affect T, and it's not going to affect R. And there we go, it's still zeros. And T is still all those random values. All right, so I'm going to stop here because I think this is becoming a long video. But hopefully this helps someone get through some of this material. And I thank you for watching me. Be sure to like and subscribe, and if you have questions, go ahead and ask them. Bye-bye.